Okay, chapter 7 is about the null hypothesis. We've spent a lot of time looking at things about significance level, and that's where this is going to really come into play. In essence, null hypothesis is a statement about a research topic where you're saying there is no difference between two groups. Sometimes this is done verbally, sometimes numerically. For example, I could say there is no difference in the GRE scores of men and women. Numerically, it would look like this down here at the bottom, that the mean scores of GRE men is equal to the mu GRE scores of women. Those are two equal things. I'm saying there is no difference between those two things. They don't have to be scores. They can be correlations, they can be standard deviation, they can be anything else. And this, rather than having you do this in groups, I'm just going to give you another example. It's possible to say that the ACT scores of students at one high school are equal to the ACT scores of students at another high school. Or the SAT scores of students in high-income schools are equal to that of SAT scores of students in low-income schools. You can also do this with multiple groups. It's possible to say that the SAT scores of high-income students are equal to median income students and are equal to low income students. And all we have to do to reject that equation is to make any part of that equation not true, to knock out any part of that equal sign, and then we can reject that null hypothesis and say that those two things are not equal. Now, these are not made up. This is why we do the lit reviews, so that we can start building a case for what we want to do. I'm trying to think of another example. With your research, one of the students has a issue with sports in college. So we could say that the experiences of students at an NCAA Division II college are equal to the experiences at NCAA Division I college. And I know that's probably not right. We don't use Division I and II anymore, I don't think. But anyways, those two things are equal. And you're doing research to try to figure that out. We're not out to prove anything, only to reject or fail to reject the null hypothesis. And this is where this kind of gets confusing, because this kind of turns into a double negative. So let's say that we take these GRE scores of men and women. If I reject that, then all I've said is, based upon the sample that I took, these two sets of GRE scores, the men and the women, are not equal. I've rejected that null hypothesis. That doesn't mean that I proved it's true. I just rejected the hypothesis that I set up. If I look at the SAT scores of high income, middle income, and low income kids, and I reject it, then that means either the high income is not equal to the middle income income is not equal to the low income, or the high income is not equal to low income. It can be any one of those things to reject that null hypothesis. Remember, null hypothesis means there is no difference. If I fail to reject a null hypothesis, that means that as far as I know, for the data that I gathered and the sample that I have, I was not able to reject it. And as far as we know, those two things are still equal. So for the GRE scores in men and women, if I fail to reject it, then as far as we know, those two sets of scores are equal. Another aspect of this is they can either be directional or non-directional. And non-directional means that we don't know what to expect. We just think there is a difference. And this is kind of a safe bet, especially if you're stepping off into an area that you don't know a lot about. The directional means that we're going out on a limb and saying one is higher than the other. So, for example, my alternative hypothesis might be that the GRE scores of men are higher than the GRE scores of women, that their mean score is further to the right on that normal curve than the GRE scores of women. And this leads us to something called tails. What they're talking about when you see things about tails in the reading is, if we look at this normal curve, remember the GRE scores. If the GRE scores of women are here, and I'm going to go out on a limb and say the GRE scores of men are higher than the GRE scores of women, I'm getting out on this tail. So sometimes you'll see something about a one-tailed null hypothesis. What they're doing is they're going out on a limb and saying one direction or the other from the mean. If the women are here and the men are here, that's one tail, if they're saying one's higher than the other. Or they might say that the men are lower than the women, so they're going out on this tail. So a one-tail alternative hypothesis is a directional. A two-tailed means we don't know which way it is. Okay, now that we know what we're looking for, we have to collect data. And there's some important things that we need to take in consideration to do a very good job of collecting our data. As we've said before, we need valid and reliable data. We need an excellent sample. The reason this makes a difference is if our sample is not really well done, then it's very simple for people to come back and say the reason that you see a difference is not because there really is a difference in the GRE scores of men and women, for example. It's because you didn't do a good job selecting your sample. They're not diverse enough to say that there really is a difference. In that bit of confidence, meaning there's a chance you may be wrong, is what we mean by level of significance. The level we're willing to accept, let's see if we can do this. Is 0.05. That means that 5 times out of 100, the difference we see in two groups is because of who we selected, not because there really is a difference. That level is 0.05 is okay. We're willing to take that chance and say 5 times out of 100, the reason we see a difference is because of who we picked, not because there really is a difference. That's your magic number. The important things to remember: the critical value is calculated by a computer. You don't have to figure this out. The level of significance can be adjusted higher, or we'll tell you the level of significance. The researcher has to decide how sure he wants to be. It can be set up to a 99% confidence level. I mean, a 99% level of significance, or the opposite of that would be 0.01 or a 0.01 level. And the higher that you make the accuracy or the significance, the more sure you can be that the differences you see are because of true differences, not because of who you pick. You don't have to try to figure all this stuff out. It will always tell you whether or not it's significant and how significant it is. As I said, 0.05, and anything less than 0.05 is our magic number. We have to have it less than 0.05 for it to be a significant difference.